Welcome to this deep dive brought to you by Safety One Source. Today we're tackling a really vital area for safety professionals, risk managers, anyone really committed to a safer workplace.
Absolutely.
We're looking at understanding and controlling hazardous airborne substances, stuff you find in construction, general industry, all over.
It's a huge topic.
It is. And you've given us this really detailed set of regulations and guidelines. Our mission today really is to sort of cut through that complexity.
Yeah, make it digestible.
Exactly. Highlight what truly matters when you're managing things like dusts, fumes, mists, vapors, gases. We'll focus a lot on ventilation and PPE, personal protective equipment.
Crucial elements.
Especially in demanding operations. Think abrasive blasting, grinding, that sort of thing. Okay, should we get into it?
Let's do it. It's definitely a cornerstone of workplace safety. And these materials, they give a pretty comprehensive look at OSHA's expectations. What's really fundamental right from the start, 1926.57a, is that the concentration, the amount of any hazardous substance in the air, it just must not exceed the limits.
The PELs, right, permissible exposure limits.
Exactly, those limits in 1926.55a. And think of them not just as, numbers on a page.
Mm-hmm.
They represent that tipping point. The point where workers can suffer serious health effects, sometimes irreversible ones.
That really puts it in perspective.
It does. That's the core principle driving all these detailed ventilation rules we're about to unpack.
Absolutely. So it's definitely not just about, sticking any old fan in the corner.
No, definitely not.
The rules, 1926.57b, they're clear. If you use local exhaust ventilation, it has to be specifically designed to capture contaminants at the source.
Right there where they're being generated.
Yeah, and stop them spreading into the general work area. It shouldn't be pulling that hazardous air, right through where people are breathing.
Seems obvious, but it has to be said.
It does. The regs spell it out for a reason, I guess.
Exactly. And it's a whole system approach. Section C, 1926.57c, it talks about the need for proper design, strong construction, keeping it maintained.
Maintenance is key.
And operating it correctly. Every single part.
Yeah.
Fans, ducts, hoods, the collectors, even the bins for the waste.
The whole chain.
The whole system. It needs to keep enough airflow, enough velocity to actually grab those contaminants and move them somewhere safe for disposal. Make sure they don't just recirculate or cause trouble down the line.
And the timing when these systems run, that's crucial too, isn't it?
Oh, definitely.
Section D1 says the exhaust has to run during all the operations it's meant for.
Makes sense.
But then D2 makes this really important point about microscopic dust, the tiny stuff.
Yeah, the stuff you can't even see.
Right, it can stay floating in the air for a surprisingly long time.
Much longer than people think.
So just switching off the ventilation the second the grinder stops, that might not cut it.
No, that system might need to keep running for a bit, clear out those lingering hazards.
It's a good reminder for anyone using respirators, too. Don't just whip it off the moment the main task starts.
That's a critical point for safety pros. That invisible, lingering dust.
Yeah.
It's a real threat. Easily underestimated if you only think about the immediate job. And Section E covers what happens to the collected stuff. Just as important as capturing it.
Right. Disposal.
Generally, the exhaust air needs to go outside. Any collected dust, waste, handle it safely, dispose of it safely, prevent secondary exposure.
And recirculation.
Only allowed under very specific conditions.
Yeah.
You have to absolutely guarantee no harmful exposure back in the workplace. It's a high bar.
Okay, good to know. Now let's dig into abrasive blasting, Section F.
Okay.
The regs here, 1926.57F, they seem incredibly detailed, which makes sense given the work.
It's a high hazard operation.
We're talking about forcefully propelling abrasives. Right away, the definitions and set the stage, defining terms like abrasive blasting respirator, blast cleaning enclosures.
And respirable dust.
Yeah.
Very important one.
Why is that level of specific definition so important here?
Well, the precision is vital because abrasive blasting, just by its nature, creates a massive amount of very fine respirable dust.
Stuff that gets deep in your lungs.
Exactly. Section F2 highlights this. Both the abrasive itself and whatever coating you're blasting off, they get pulverized. Tiny particles, easily inhaled.
And potentially toxic, depending on what's being blasted.
Highly toxic, potentially. Think silica, lead paint, other heavy metals. So 2 then emphasizes that the concentration of this respirable dust right there in the worker's breathing zone must be kept below those PLs we talked about.
So high risk demands very specific controls.
Precisely. And one key control is using those blast cleaning enclosures.
Right. Section F3 mandates them and says they need exhaust ventilation that creates continuous inward airflow through all openings.
That inward flow is the crucial bit. It contains the dust.
Like keeping smoke in a box, you need air pulling in, not pushing out.
Exactly, like a slight vacuum. Any air movement through gaps is into the enclosure. Keeps the dusty air contained so the exhaust system can grab it.
Makes sense.
And F3IA goes further. Talks about baffles, placing inlets and access openings strategically, all to minimize dust escaping.
Okay.
The exhaust rate, mentioned in B, has to be high enough to clear the dusty air quickly after blasting stops.
And critically.
Critically, yes.
Yeah.
F3IC says you turn off the blast, let the exhaust run for a period before anyone opens the enclosure.
Containment first.
Containment and control clearing. It's all about managing that dust.
The regs also get specific about the enclosures themselves. Safety glass for windows when using hard abrasives.
Yep.
Slit abrasive resistant baffles at small openings. Tight-fitting doors on rooms. Operable from both sides. That's in D and E.
They're designed for maximum containment during operation. Absolutely.
And the exhaust systems for these blasting setups, Section F.
They have their own strict rules, too. They reference ANSI standards Z9.2 and Z33.1 for construction, installation, inspection, maintenance.
So established industry standards.
Right. Prompt repair of any dust leaks is essential. And they require periodic checks of the static pressure drop in the ducts.
Static pressure drop, like checking the system's suction power.
Exactly like that. Think of it as the strength of the vacuum. If that pressure drops significantly, it's a red flag. Something's blocking the flow-clogged duct, full filter.
And the system's not working effectively.
Precisely. Its effectiveness is compromised. And for systems that recirculate the abrasive material itself,
Yeah.
the regulation mandates a separate abrasive separator. You can't just rely on the main enclosure exhaust for that fine dust.
Okay, separate systems.
And finally, the air exhausted from the blasting equipment must go through dedicated dust collectors, designed so you can safely remove and dispose of that collected dust.
Got it. Now, what about when you can't use a full enclosure? Or when a worker actually has to be inside one during blasting?
Ah, that's where PPE, especially respirators, becomes absolutely critical. Section F5.
Mandatory IOH-approved respirators.
Mandatory, yes. And the regulation is very specific about the type of respirator needed for the situation.
Like what?
Well, abrasive blasting respirators, the ones covering the head, neck, shoulders, they're required inside blast cleaning rooms.
Okay.
Also for manual blasting with silica sand if there's no separate enclosure. And basically any time the toxic dust limits might be exceeded without an enclosure, that's all in 5.
So the highest level of protection in those cases.
Right. Now for shorter, intermittent tasks like cleanup,
Yeah.
maybe a properly fitted particulate filter respirator is okay, but it must be NIOH approved for that specific dust type.
And there's more to it than just handing out masks, right?
Oh, absolutely. This is crucial for safety professionals. Mandates a comprehensive respiratory protection program whenever respirators are needed.
Like the program outlined in 1926.103.
Exactly that one. It's a whole system. Fit testing, medical evaluations, proper training, cleaning, the works.
Yeah. It's a complete program. And beyond respirators.
The PPE section also calls for heavy-duty stuff. Canvas or leather gloves, aprons, safety shoes.
Meets the ANSI standard for footwear.
Right. And eye and face protection if the main respirator doesn't provide it or for other people nearby the blasting.
A layered approach makes sense.
It is. And don't forget the air supply for those abrasive blasting respirators mentioned in F.
Oh, yes, the air itself.
It has to be absolutely clean, free of harmful contaminants. It needs to meet the specific requirements in the General Industry Standard, 1910.134I.
Because breathing contaminated air through your respirator is, well, pointless.
Exactly. It defeats the whole purpose. That clean air supply is paramount, often overlooked.
And then Section 7 covers operational procedures, general safety.
Yeah, basic but important stuff. Preventing dust buildup outside enclosures, cleaning spills promptly, keeping walkways clear so people don't slip on stray abrasive.
Tying it all together.
It's that holistic safety approach.
And the scope, Section F8, clarifies it covers forceful application of abrasives, pneumatic, hydraulic, centrifugal, but not things like steam cleaning without abrasives.
Pretty clear definition.
Now, this brings us to something interesting, an OSHA interpretation letter from 2015 about wet abrasive blasting.
Ah, yes, that one. Addresses some newer tech aimed at dust suppression.
So what's the main point there?
The key takeaway is about the respirators. Those Type CE continuous flow supplied air respirators. They are not automatically required for wet abrasive blasting if, and this is the important part, if the employer can demonstrate that the toxic dust concentration in the operator's breathing zone stays below the PELs.
Okay, so there's an out, but you have to prove it's safe.
Exactly. It's not a free pass. There are specific conditions in that letter, very specific criteria to meet the exemption.
Such as?
Well, rigorous personal air sampling, conducted outside the blast unit's shroud, right in the operator's breathing zone.
Not inside the protective gear.
Absolutely not inside. It has to show exposure levels will consistently stay below the PLs. Use accepted methods. Make sure it represents the actual work. Don't give any credit for the respirator being worn during the sampling.
Document everything thoroughly.
Document everything. Plus, the operator needs to be working inside an exhaust-ventilated enclosure that separates them from the nozzle and the blast itself.
Still need containment.
And fundamentally, the employer still has to comply fully with the main respiratory protection standard, 1910.134.
Got it. So it's a high burden of proof for the employer.
Yeah, it is. The letter also clarified the definition of Type CE respirators. Includes NOHH-approved supplied air types that offer head-neck protection, not just continuous flow ones.
Aligning with OSHA's terms.
So to broaden the scope of what could meet the requirements if the exposure assessment backs it up.
And you mentioned sampling outside the PPE. That seems critical.
Absolutely critical. The 2015 letter hammered this point home, echoing an older 1999 letter. Sampling inside a hood or respirator, it would seriously underestimate the actual potential exposure.
Why is that the benchmark, the unprotected level?
Because OSHA needs to know the baseline risk. What contaminant level would the employee face without protection? That's what determines if the controls are adequate and which PPE is necessary.
Okay, that makes perfect sense for risk assessment. Know the real hazard first.
Precisely. The 1999 letter also touched on potential issues with lead sampling using steel grit, though it didn't have a final solution then. But it did confirm OSHA's methods for lead, cadmium, arsenic were considered accurate enough, factoring in normal sampling and analysis variability.
Then as science evolves, right, particle size sampling.
Yes, the agency acknowledged those discussions were happening and they were following developments. As for putting deflectors on sampling inlets, the 99 letter mentioned an iOS study found one design ineffective. Basically, you need solid data to support modifying standard sampling gear. The message is consistent, accurate, representative sampling in the breathing zone outside the PPE.
Okay, let's shift gears. Grinding, polishing, buffing operations. Section 1926.57G.
Right, another common source of dust.
Similar structure here. Starts with definitions in G1. Wheels, belts, exhaust system parts.
Sets the stage.
And the core requirement in G2. Local exhaust ventilation is mandatory if employee exposure from dry grinding, polishing, or buffing goes over the PLs. Again, assessed without respirators.
Control the hazard at the source. That's the recurring theme.
It is. Then G3 gets into the specifics for hoods and branch pipes in these exhaust systems.
Key principle here. Hoods need to be designed and placed to actually capture the dust effectively. Pull it away from the operator's breathing zone in the direction the air is already flowing from the wheel or belt.
And it gets very specific, doesn't it, with tables?
Incredibly specific. Table D57.1 gives minimum exhaust volumes, recommended duct velocities for different grinding wheels, even tells you how to calculate for wider wheels.
Wow. And there are more tables.
Oh, yeah. D57.2 for scratch brushes, buffing, polishing wheels. D57.3 through .6 cover different disc grinders and abrasive belts. It's clear the ventilation needed really depends on the exact equipment.
No one size fits all.
Definitely not. And for bigger stuff like cradle and swing frame grinders, where you might have a partial enclosure instead of tight hood, Section G3 specifies a minimum average air velocity, 150 feet per minute across the opening of that enclosure, ensures enough inward flow to keep the dust contained.
And if the workpiece sticks way out of the hood...
Good point. Section G3 acknowledges that. If the work extends significantly outside the hood, capture is less effective, so you need to bump up the exhaust volume. It references ANSI Z9.2 for guidance on that.
So adjusting for real-world conditions.
Exactly. The exhaust systems themselves, covered in G4, also need design and testing per ANSI Z9.2. And critically, all these systems must have suitable dust collectors.
Right.
Got to remove that captured dust from the air.
Right. Then G5 gets into the design of the hoods and enclosures themselves.
Yes, and it stresses the dual purpose of grinding wheel hoods. Capture dust, obviously.
But also protection from bursting wheels.
Exactly. A robust physical barrier. They need to meet structural strength standards from ANSI B7.1. Hoods should also be adaptable, fit the machine well, and be located as close as possible to the action. Maximize capture.
And there are figures illustrating these.
Lots of figures. D57.2 shows typical grinder hoods, including that adjustable tongue piece.
To keep it close as the wheel wears down.
Precisely. Then you've got figures for exhaust booths for swing frame grinders, D57.3, hoods for polishing buffing, D57.4, enclosures for cradle grinding, D57.5, specific designs for horizontal and vertical disc grinders, D57.6, .7, and .1, belts too, D57.8.
The level of detail, the visuals, it really drives home that these controls need to be properly engineered for the specific machine and task.
It really does. Generic ventilation just won't cut it for these operations. And G6 clarifies the scope, controlling dust, dirt, fumes, gases from working with both ferrous, iron-based metals, and non-ferrous ones.
Okay. We also had brief mentions of spray finishing in H and open surface tanks in I.
Right, touching on other areas.
For spray finishing, the key seemed to be using enclosed spray booths or rooms. Containment again.
Containment is huge there.
And proper ventilation is critical. Minimum air velocities into the booth, table D, 57.7, keeping solvent vapors below 25% of the LEL, the lower explosive limit.
Crucial for fire and explosion prevention.
Plus needing adequate makeup air, heating it, filtering it.
It's a well-balanced system.
And for open surface tanks, where you dip things in liquids or vapors?
Yeah, for surface treatments. The regulation classifies those operations based on hazard potential, how fast vapors or mists are generated, using tables D57.9 and .now.
And based on that classification,
you need adequate ventilation. Tables D57.11 and .1 do give required control velocities for different hood types, enclosing lateral canopy hoods.
And other controls might be involved too.
Right. It briefly mentions things like tank covers, foam blankets to reduce vapor release, and of course the need for appropriate PPE for workers doing those jobs.
Okay, so as we start to wrap up this deep dive, a few key takeaways really stand out, especially for our listeners, the safety pros, the risk managers out there.
Definitely.
We've seen just how fundamental it is to not just know about, but really understand and stick to those OSHA pales for hazardous substances.
Non-negotiable baseline.
And the design, the proper installation, consistent maintenance, and just making sure they run correctly. Effective ventilation systems are absolutely critical, especially for those high dust jobs like blasting and grinding.
Yes, and the regs give such specific details for local exhaust. The hood design, capturing at the source, sizing the ducts for proper airflow, maintaining the dust collectors. It's all laid out.
And when engineering controls aren't enough on their own, or for specific unavoidable exposures,
that's when PPE comes in. Yeah. Correct selection, consistent use of OSHA PATE-approved gear, especially respirators. Absolutely mandatory.
And that OSHA interpretation on wet blasting really highlighted something important.
Accurate exposure monitoring, yes. Sampling outside all the PPE. That's essential to truly know the risk to workers and to check if your controls are actually working.
It really makes you think, doesn't it? How do these detailed rules and best practices apply day to day in the workplaces our listeners oversee?
Exactly. Are the ventilation systems really designed and maintained to these standards? Are workers using the right PPE for the actual hazards?
Is the exposure monitoring thorough? Accurate? Reflecting the real potential risks?
These are the questions to ask. And for anyone wanting to go even deeper, the specific OSHA standards we mentioned, 1926.57, 1910.94, the substance-specific ones like lead, arsenic, cadmium, plus 1910.10000 for air contaminants and 1910.134 for respiratory protection.
And the ANSI and NFPA standards reference.
Right. They offer a huge amount of technical detail and guidance.
So here's a final thought for everyone listening. How can safety professionals proactively push beyond just ticking the compliance boxes?
Good question.
How can you really identify and mitigate potential airborne hazards before they cause problems? Foster that culture of prevention, continuous improvement, create a work environment that's not just compliant, but genuinely safe and healthy.
It's about looking beyond the checklist, isn't it? Being proactive about those often invisible dangers.
Exactly. Well, thanks for joining us for this deep dive brought to you by Safety One Source, aimed at safety professionals, risk managers, and anyone dedicated to boosting their workplace safety knowledge.